Alright guys, I'm just going to spend a few moments going over some of these problems, not necessarily working all of them out, but at least talking to you about what you need to do. Starting with number 1, in order to convert a fraction to a decimal, you just got to remember you got to divide the top by the bottom. This particular one, when you do it, gives you 0.045 repeating. So since we can't put that line over it like we usually do, for this answer you just need to type the word repeating. So it should be 0.045 repeating because we cannot put that line in there. All right, number 2, it's saying which numbers are irrational. So going back to rational versus irrational, all numbers are rational except for a very select few. The only irrational numbers are numbers that keep going without a pattern, like decimals, like 2.34782, and there's not an actual pattern. That's the only thing that when I do an imperfect square or anything like that and I get this, that's irrational. Everything else is rational. So all fractions, if I have a square root and it comes out to give me a whole number, positive numbers, negative numbers, regular decimals, or if I have a decimal that repeats a pattern, those are all rational. So the only thing that's irrational is these numbers that keep going without a pattern, and sometimes they're hidden in things like square root of 17. Well, that's not a perfect square. It's going to give me some crazy long decimal. So the answers for number 2 should have been the two that don't give me a perfect square, which are square root of 14 and square root of 43. For question number 3, you needed to actually take the time to write it down and work some things out. You need to combine like terms, so 6 minus 2x equals negative 4x plus 8. You need to get your like terms on the same side. I would add 4x to both sides, and I'm left with 6 plus 2x equals 8. When I minus 6 from both sides, 2x equals 2, so x equals 1. Number 4, you need to classify the equation based upon the number of solutions. So this is technically a system, but it looks like just a regular equation. But you've got variables on both sides, and your first step is to distribute the 8. So you've got 64x plus 24 equals 64x minus 7. Well, already I can see I have the same coefficient, so those will go away, and I'll be left with 24 equals negative 7, which is false, which means no solutions. All right, number 5, you need to solve for y. So the opposite of squaring something is the square root, but when I do it to one side, I must also do it to the other. If I'm taking the square root of the whole fraction, I really need to just know I need to take the square root of the numerator and denominator separately, because if you put that in the calculator, it's going to tell you 0.6, which is equivalent, but we want the fraction. Square root of 9 is 3, square root of 25 is 5, so one of my answers is 3/5. Remember, square roots could have been positive 3/5 or negative 3/5. If it was a cube root, it only has one answer. Use the properties of exponents to compare those two expressions. Well, 16 to the 8th is already kind of solved there. 4 to the 5th power to the 3rd power, when you got a power to a power like that, you really multiply it. So this I'm looking at 4 to the 15th power. Well, just by this format, I mean, you could probably reason which one's larger, but you don't actually know. What you can do is think of 16 as 4 squared, and then that's to the 8th power. And now I can compare them because I have similar bases. So this would really be 4 to the 8 times 2 is 16 power. The other one's 4 to the 15th power, so the first one's larger. So it is greater. Number 7, you need to simplify the expression. So in your calculator, you can type in that thing exactly, making sure you put them in parentheses. And your calculator, if you go to second DRG and arrow over to science, we'll put it into scientific notation and give you your final answer. When you multiply it out, it should be 2.7 times 10 to the negative 10th. Number 8. You are looking at a 15-inch candle that burns at a rate of 1 inch per hour. So if I'm looking at these graphs, the y-axis is representing the height. If it is burning, the height of the candle should be coming down, so it must be C or D. Specifically, I'm looking at a rate of 1 inch per hour, so I'm going to look for which one of these is going at a rate of 1 inch per hour. This one looks like it is. This one also looks like it is. So the question is, this one is not connected and this one is. So that's saying that every hour, it only just randomly drops an inch. Then an hour passes and then it drops an inch. Or is it a continual process? Well, I think it's a continual process. Therefore, D is the correct answer. All right, question number 9. The amount of money Y Pizzeria K makes by selling X pizzas can be modeled by Y equals 17X. The relationship of the amount of money Pizzeria L makes is shown in the graph. Which one makes more money? So basically you're comparing more money per pizza. You're comparing the rate of change from this equation and this graph. So the first one is $17 per pizza. The second one, if I look at the rate of change here, I'm finding some good points. I've got the points 230, I've got 115, 0, so this is a directly proportional line. I really can take any one point and divide y by x to find my rate of change. So like for example, the point 230, I could really just take 30 and divide it by 2. Now if you don't remember how to do that, you could have also just taken 2 of these points. You could have said 115 and 230 and done y2 minus y1 over x2 minus x1. And that would be 30 minus 15 over 2 minus 1, which still gives you 15 over 1. So the second pizzeria, Pizzeria L, is making $15 per hour. The first one's making 17. Therefore, the first one is making more money. So Pizzeria K makes more money. All right, and number 10, graph each equation, determine solution to the systems of equations. Okay, well, technically, you could solve it by another method. Even though it says graphing, honestly, I would probably use elimination because they're already lined up, and I have a 2 and a 2 over each other. So I just need one of them to be negative, so I'm going to pick an equation, multiply by -1, because I'm only trying to change the sign. So that will now give me a negative x minus 2y equals -4. And a 3x plus 2y equals 0. So y's cancel. -1 plus 3 will leave me with 2x equals -4. So x equals -2. That's only half of my answer. I have to plug that value back into either one of the original equations. I'll pick the top one. So if I plug it in where x is in this top one, I've got -2 plus 2y equals 4. So I'm going to add 2 to both sides. And 2y equals 6, so when I divide by 2, y equals 3. So my ordered pair is the ordered pair -2, 3. Make sure you put your parentheses around it.